Hey guys, welcome back to the channel. So DP, we're going very slow with the DP. Uh, well, we completed 15 problems out of 49. On to the next problem on the DP list. Lead code 416 and acceptance rate is very low, but the number of participants is very high. So I guess this will be okay. Lead code medium level problem 416 partition equal subset sum. Let's see what we have to do. We have an integer array nums and we have to return true if you can partition the array into two subsets. The array can be partitioned into two subsets such that the sum of the elements in both the subset is equal or false otherwise. Okay. So for example, if we take 5 subset, right, 551 should be one subset, 11 should be another subset, 155. Okay. Here we cannot. Okay. Let's see. So let's do try all. So we have two options for each value. Let's take value 1 and value 2. I think we also need an index. We have two things. So the base case is if value 1 index equals to is just if index is equals to length of nums and return val1 equals to val2. So we have two options in our hand. One is to keep an element in first subset or keep the element in the second subset. So val1 plus nums of index comma val2 and return or if one of them becomes true, then we don't need to search anymore. So this will short circuit. Index is 0 initially. value 1 is 0 and value 2 is 0, and the number of items will be 1 to 200, so that will be good. So we need to understand, we have to print all these values and see how many times a combination is repeating approximately. 0 is 0, number 1 0, 2 3 0, 3 6 0, 4 11 0, 4 6 5, 3 3 and 3, 4 8 and 3, 4 3 3, 3 4 2, 4 9 2, 4 4 7. Since we have two operations for each index, we'll have two power and number of, we have to do two power and number of operations. 0 1 2 3 4, 4 3 4 4, 2 3 4 4, 3 4 4 4, 1 2 3 4, 4 3 4 4, 3 3 4 4, 3 4 4. But it is not, like, it didn't seems like a, what do you call it, a DP problem. But instead of we using val1 and val2, we re, we return an array of 0 comma 0. Now we have to know, one thing is, we can add the current index value to the 0th element or to the postillion. For now, we'll continue with this. and again when the loop is broken, what do we have? Do we have 11 and 11? Oh, no, sorry. But instead of going through this hell, like all this hell, even though I use LRV cache, it won't be any good because it still runs through all the iterations because there are these many factors involving, three factors involving, which gives a huge number of combinations. So it didn't seem like a DP in like anything like a DP approach because this won't be helpful. On top of helplessness, it consumes so much of space. So instead of doing all this shit, let's copy this. I copied it. So let's just sort the nums. And let me try submitting this for now. After that, let's see the topics. If it worked out, yeah, that's what I thought. Let's see the topics. We have to ditch these value 1 and value 2. Let's do one thing. Let's keep value 1 and value 2 and 10 equals to 10 dot 9. We don't need index. Ten. Value 1 and value 2. If we remove it, and this 2. This is not helpful at all. Well, we implemented a brute force approach, but it is not perfect at all. Let's do one thing instead. Let's say Instead of using two values, let's keep total equals to uh, sum of numbers, and let's total. We pass total into it. If total person 2 return false, or else if total is divisible by 2, and the values will be between 1 and 100. So if somewhere rem is less than 0, then we have to check remaining equals to, or let's remove another caching and print index mean, I bad. 022 1 121 216 3540 40 35. If the value will be between 1 and 100, we equals to 0. 0 0 121 216 35 4040. We went back to 3 comma 5 4040. Went back to 216 354040. Okay, we are getting now the required values 216 216. So now DP would be helpful, but we are getting false here. We need to have 11. Five. Oh, sorry. So either we will have the index used, or the index will go to the next one. 0, 22, 121, 3, 40, 45, 3, 16, 411. And let's see what about this. I think now the memory limit will exceed. Oh, it didn't. Great. Well, we should try doing it now. Probably the sum might be odd. Let's do if then. Similarly, cache. I think the time limit will exceed now. Oh, output limit exceeded. 0. 76, 74, 74, 73, 74. Do we have 174? No, 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 no. We have so many lines. What if we do this? Reduced by a drastic amount. Now we see printing to the console is as big as doing some operation. Now let's try submitting this. Though it worked out, we used up a very huge chunk of memory and so much time to. Let's see what others did. If total sum and 1 equals to 1, that means if the total sum is uh, odd, then returning false. Target equals to total sum by 2. Uh, they are using bitwise operation. Okay. Target equal to 1. We don't know bitwise operations for now. Let's see the majority submission. This seems like simple. Let's see. Total sum. Okay. Target. Good. This equals to false into target plus 1. Okay. Target number of that is half of the total. DP of 0 is true. Now, if now going to each number, order sum into for j in range of target sum minus 1. Okay, we are going from target to the num minus 1. That is halfway to the number dp of j equals to dp of tr dp of j minus number. Okay, we are checking this. It's like adding the number. This is a subset where we won't add the number. This is a subset where we will add the number. So we tried without like taking a number from the list, some list, and we are deciding whether not to add or to add. If adding if somewhere it becomes true, then we will end up at the target because we start from target every time. If somewhere target becomes achievable, then okay, let's try to do it. We are going in the backward direction, huh? Just take target will be 11 and 11 to 1. 11 j minus number or j becomes j won't become 0 anytime. But if j minus num becomes 0, then Z position will become 0. Well, I understood until like what's going, but I couldn't understand why is this true? Why is this working? Going through each number and target, starting from target to the number. If the number is bigger than the target, then the loop won't continue. Understand, but I have an animation of the open nested array scale. So different sizes. Okay, now scales of different sizes. At each position, From zero to target. Expansion of which is a box. We combine some weights to make exactly half the total weight. If we can a scale not label the scale zero to target and CBF is equal to 2 means it is possible to make weight W using weight W. Using some of the weights we have seen so far, it is possible to make using some of the weights we have seen so far. Okay. Initially because because we can always make weight zero by choosing nothing. All other slots are false. Each weight num is like a new building block. When you see a weight num, it gives you new possible weights you can form. If it could previously form weight j minus num, then by adding weight num, we can also form weight. Values within the same equation, which means we will effectively use the same weight multiple times. Guys, for now, uh, this code stress my brain a lot. I am gonna check it again after some time. Then probably I might understand. So I hope you guys understood this intuition which is mine, where we are taking the index and the remainder minus the current value. The thing is, what we are doing here is we are going through each index, index 1, index 2, everything until the final index. And when we reach the final index, we are checking if uh, the remainder we got is half the total. That means we have half removed and we have the remaining values each will be equal to the half. So for each value in the list, we can decide whether to keep it in the list 1 or the list 2. If we keep it in the list 1, we remove from the remainder. If we keep it in the list 2, we keep the remainder same. So that's it guys. I hope you guys understood the intuition. If you like the video, upload it and share it with your friends, and don't forget to subscribe to the channel. We'll meet you again with another video. Until then, keep learning and keep pushing hard. For now, we have to leave it like this, and we'll fetch it, like we'll try to fetch the answer eventually. So goodbye guys. The time complexity is 2 to the power n into m higher. Okay. So that's it guys. I hope you guys understood the intuition. We'll meet you again with another video. Until then, keep learning, keep pushing hard, and stay motivated. Goodbye guys.